We are here today to speak in regard to fire-rated weatherproofing systems, find out the most advanced technology for your projects. I'm here with Enrique, responsible for the UK market.
Hi, everybody.
And I'm from the technical department. So we hope to have a nice time here with you guys. Even knowing the situation outside, it's not as we hope, but let's find in other things. Let's talk about interesting things. And today we choose to speak about fire-rated weatherproofing systems. We will be here for talking all the days, answer day, and then that's all. So there are another thing that I'd like to keep your attention. There are a chat below that you are most welcome to chat, to make questions, try to interact to us, and we are most welcome to reply and to speak with you. Okay, so if I start, usually we see. We look into these pictures and we see a rain screen cladding typology of the facade. It looks beautiful, it looks feasible, it fits the purpose. But in the end, we see, and then somehow we see sometimes this kind of things, it happens. So it's not only on the same country, it's not only in the same year. Typology of the facades are totally different. So why? So the point is why these things keep on going. So and we see that it's more than what we expect. For instance, I pick up here. I pick up the most critical of them. So you see Russia in 2007, 2 deaths. Grenfell Tower, unfortunately, we know. Marco Polo Apartments in Honolulu, 3 deaths. We see in 2015, not far away from now, 17 deaths. France, 1 dead. Shanghai, 53 deaths. So why this happened? So we believe that it's, for instance, in the other disciplines, as a structural design, concrete design, thermal design, these things are not happening. So why it's happening in terms of fire? And one thing that I would like to say here, it is fire becomes nowadays in the facade, becomes not more technical, but it's a question of liability. So I think we, the facade players, needs to work together to find a way to solve the issue. And this comes to my next slide. Why the fire remains an open discussion? So we never know what are the, in general, a lot of discussion, a lot of confusion. So each country, they have their own rules. And I'd like to bring here some of the inputs that it's part of the fire design, but in general we see we don't see like a common agreement, a common guideline, a common like a book as we have in other engineering disciplines. So is that, for instance, we generally know that the facade, the fire propagates from the exterior. Balconies is an issue. A lot of combustible organic materials on the balconies. Inside a flat, a kitchen, break the window, and then the fire will propagate. And then when there are a fire and it reaches to a rain screen cladding, we have the worst case scenario conditions. So we have oxygen, we have airflow, and then I'd like to keep your attention here. We have the worst scenario conditions. So we have like a chimney inside of our facade. Imagine high temperatures, the fire will not propagate for. So imagine in a couple of minutes we will have the full facade with fire. Here it's some diagrams and how the implication of the airflow in the height of the temperature. Here it's a small example. If we create in a facade like a horizontal projection, the fire needs to turn this, and it's not going. It lay down the propagation. For instance, the way that the facade, the way that facade is designed, it's also implications on the fire. U-shape, it's also U-shape constructions. It's also not a good option in terms of fire, because the fire it's totally there. But there are a lot and a lot and a lot. So what my point here is, uh, we need to find a way that working together as a group with the institutions, and otherwise it's working project by common sense. And it reached to next slide. So what they are doing, the regulations. So the regulations are trying, because of this quite of so difficult, it looks that it's so difficult to predict the wind, to predict the fire load, to predict the geometry. So should we do a full-scale mock-up? It is a full-scale mock-up replicating my facade. Sometimes no, sometimes yes. So what the regulations are trying to do, it's laid down in a way that each materials in the facades to be non-combustible. So in a way that if we reach that level, we will not have a fire on the facade. So this is what it's happening in UK. UK in general, there are a combustibility ban that all the materials should be class A2 non-flammable. However, there are examples, there are exclusions, membranes that are one of them, but there are also discussions to improve for class A2. So we see really a line for the class A2, and whatever that the industry could deliver non-combustible, the facade industry are will. We see in Dubai as well the same class A2 S1D0. We see Norway, we see Sweden, Italy. I believe that next year will approve the class A2. So we see the regulations are going tight and tight, and this is the way that we avoid, at least until we have a guideline, a document. This is only the way that to restrict or try to minimize fire propagation on facades. So this reached to a point that how Effisus could help in this. How can we contribute to this fire thematic? So here it is really a simple scheme. When we have mass production, so it's the industry delivery, the client has sometimes fulfilling the requirements, sometimes not. And what it's coming now, it is the industry do not have solutions for a lot of problems. And Effisus, since our methodology, it is to be really, really close to our clients, to understand their needs, we are able to do another game. So we have plenty of R&D projects, developing solutions that fit and help our clients in the end. And these fire-rated systems comes exactly through this system, through this methodology. So here, to be really, really focused on the membranes, on our systems. So we have breather membranes technology, a sheeting membrane, that we have a VCL membranes technology. We also have EPDM technology, a lot of prefabrication, custom made, bespoke solutions, and then supported but a consulting department. And today we will speak only on the breather membranes technology and vapor control systems, fire rated. So here, if we visualize, as you know, I will not take time here explain, or I'll try to be really fast. What is the function of breather membrane, traditional and vapor VCL membrane? But in general, I believe that you know. Anyhow, there are another sessions that we focus it to explain what are the function of the breathers, what are the portfolio, what are the problems. So today I'll try to be really fast on that regards. So now it's with the Effisus breathers. So Effisus has more than one types of breather, open joints, closed joints with high tensile strength. But today we will speak in regards to fire class A2. And we reach to this membrane. It is a membrane that we are currently using since 2011. We have this technology, unfortunately, since 2011, and we felt, or we are facing this pushing after the disaster in London. So anyhow, moving away from that, the membrane, it's a vapor permeable, so it allows the vapor, if any vapor inside the insulation, it allows during the summer seasons to go out. It is watertight, it is window tight, it has a fire reaction class A2, along tested, standalone and tested with accessories. When I'm saying accessories, it is tape to fix to the substrate, a tape to seal the overlap, and the tape to seal nail screws perforations. Really important. It is CE marking, and then it's also possible to customize in a self-adhesive bands, unlimited widths. And in the end, really extreme UV resistance based on the base material of fiberglass. So we in this membrane, we also have tested on ACTM E84. It's another test that obviously the results are both really good. So here it's like a summary that comparing this membrane with the standard membranes. You know, when I'm saying standard membrane, it is polyethylene, polypropylene membranes, general commodity on the market. So this graphic, I'd like to bring this graphic your attention that it's you by fire, that it's the most important. You are adding fire to your performance, but you are adding mechanical resistance as well. You could see here the difference. We are talking about 300 tensile and tear, and we are going up to 2000. So this is based off the fiberglass. It's really hard. So it's that. So you are adding in a really commodity product fire and mechanical resistance. Enrique, I'd like to collect here so the feedback from the field. So we are already applying with success this membrane. So it is really nice that we have your feedback.
Thank you, Miguel. I hope you all are hearing me well. Yes, and thank you, Miguel, for inviting me for this session. I really would like just to share some feedback from the field. I am just allow me to make here give a words to some known people that I'm seeing here attending to this meeting. So hi to everyone, in particular to those that I know. And just to get or to okay, we have a very good product. Miguel is highlighting the performance of this product, but would they be correctly applied on site? Would they have an additional difficulty to the installation on site? Not at all. So we are talking about very current installation procedure. So it's flexible membrane. It comes in a role as any other breathable membranes or other membranes that you install on site in terms of weatherproofing a facade. And so this is a very usual installation procedure. We try in every project to stay close to our customer and to the players on this job, because we really think it's important to reveal or to confirm that there's not any problem or any difficulty when installing. And so we go to the job site and we follow the installation. Normally we try to get there before the installation, of course, to give the tools that the people need in terms of knowledge of the installation. But we are here talking about self-adhesive tapes. So you just have smooth surface, clean surface. So we have also some accessories for that, liquids, cleaners. But it's a self-adhesive tape just applied with a certain spacing, and then you just unroll the membrane on top of it. One thing that I find that I'm finding from the visit to the site that I've done last month is that people find the membrane a little bit different from a current breathable membrane, and that's of course because of its composition. It's a fiberglass-based membrane, and so when you cut it, when you need to make an overlap, so it's different to manage and to handle a membrane a little bit more rigid but still flexible. But this doesn't turn into a problem on site, but it's just a curiosity, and I try to explain and to make people comfortable when installing it. But as you can see, even on the pictures, is a very normal job to be done, and so just to let you know and make you comfortable that installing a non-combustible breathable membrane, it's not having difficulty to the installation of the breathable membranes in general. Okay, and so every detail that we normally would face in a breathable membrane, we can manage here in the very same way. So it's I think, Miguel, it's more or less this that I would like to share with
Thank you, Eric. Now I was trying to understand if there are any, and you picked up well. The membrane, it's more the weight, it's more hard, or in general it is okay. It's a commodity. In terms, it's a standard application, I believe. So it's with the same a tape for fixing, a tape for sealing. So exactly the same, right, Enrique?
Yes.
Okay. So now we close the breather FR system, class A to S1D0, and then we move on for the Effisus Vapor FR system. So here we have more or less the same technology. So if we pick up our slide on the beginning that we are really close to our clients, we know what they need, fulfilling their needs. We develop technology developed in 2011, and then we come up with the Effisus Vapor FR. So the base material, it is the same, but this is a VCL. So exactly that. So the client will have the full system. Internally a VCL and external a breathable membrane, fully tested with accessories, and obtains the same classification, A2S1D0. So in the end, it is a vapor barrier, it is a watertight as well, air tightness as well, that it's really important. Fire resistance, I already spoke. CE marking, customization, bespoke solutions, it's always possible with us, and obviously UV resistance. So again, we have done the ACTM A84, and then we obtained the class A. Here it's the same than the breather FR, exactly for the same reason. We have all the technical specs with additional fire performance and mechanical performance, as well as vapor resistance. This membrane, it's more tight, more vapor tight than a standard membrane. So these allow us to have like really a block. So we know that we don't have any interactions, any convections through the interior to the exterior to the interior. And then with the right breather membrane, we always know that we have the insulation really dry. And here, Enrique, if you could do the same, what is your feedback from the field for
Yeah, sure, Miguel. And then I think we'll have already some questions from the chat.
Okay.
But I'll first comment these pictures.
Okay.
Just to conclude this topic. So yes, here for instance, we're seeing some of the pictures I took from the site regarding this VCL installation. So it's, as you see, so it's, in this case, it's fully covering the interior of the facade, so it's an SFS system. And again, the installation would be here in this case very much the same as in other current VCLs. And we came also so from the standard VCL, so class E VCL, polyethylene VCL, the most current in the market still now, I would say. But the installation is very much the same. So what we do is, so we will have the metal studs normally available, so that you can just access and apply a self-adhesive tape on top of them. And then again, you just unroll the VCL on top of it, and you seal those overlaps between different rolls, of course, with self-adhesive tape. So it's a way of installing that avoids any additional waste that you normally have from, for instance, gluing. So when you have tapes, you have normally less waste than when you're playing with glues. But also, it's a very clean job, very easy. All these instructions we give to the people on site. So we normally ask, and I think maybe we'll have a session just dedicated to the detailing itself. Right. But we look into these details. For instance, if you see the interface with concrete, it also happens. It always happens when we're talking about sealing with a VCL. And so we detail that interface and others before the start of the job, in order that everyone is familiar with the accessories that need to be installed and how to be installed and how many lines, what's the width of the tape, what's the width of the overlap. So that's something that we feel that is very important. It's not only having a good product or the product that passed every testing, it's also about installing it on site, of course. And as you can see, this is very usual, very simple way of installing. So Miguel, as I was saying, we have here some
go ahead, Enrique.
Some questions. Okay. Then from Bruno, and thank you for these questions. So from Bruno, what would be the economical aspect of deciding to sell solely the A2 membrane and stop offering all lower classified membranes? So as I was saying just now, we came from so a very normal portfolio, I would say, in terms of classification to fire. I would say from or 10 years ago, we already had VCLs, breathable membranes, so the full envelope as we try to play in every project, so controlling all all the elements that play a weatherproofing role in terms of a facade, weatherproofing. And we, at the time, we have Class E membrane, okay, in terms of breathable, in terms of PCL. And then we understood that the market and the requirements were heading this way. And we had, as Miguel already said, we had the opportunity to develop an A2 breathable membrane at the time because of the specific requirements of a specific project. As we really look into each specific project requirement, we currently, and we are doing this right now. So we have an R&D department that is, of course, developing new solutions. And so we came with this new technology for fiberglass-based breathable membrane. But since then, since 2011, that there was no push from the market for this membrane, and we had to wait for a disaster. In this case, the one that gave the most push, it was Grenfell, unfortunately, and regulations start to change. Everything starts to change, mentality starts to change, and the breathable membrane that we had developed almost 10 years ago, it starts to make sense to everybody. Okay, so I would say that at this moment we're still in a change, in a phase where we are changing our mindset, and so I can tell you that many projects, and we are not only in the UK, for instance, or only in the Middle East. We provide solutions for all the world. So some specific projects are still asking for very current membranes like Class E, and we're still producing those membranes. And so as there is a different cost of production for an A2 breathable membrane, as it's obvious, we still need to reply to so we need still to provide to the market, to different markets that have different requirements, the solution that they want, even if sometimes it is because of cost. Okay, so our arguments are normally technical, and most of all technical, but we know that sometimes the requirements are also financial and economic. So we still need to have our other levels of fire performance membrane, but we are in this kind of communication in everything we do daily, in a daily basis, to more and more point to the A2 technology that is available. It is available.
Enrique, in the top of that, so I believe that the client was asking for why stop offering the old membrane. So I believe that it's not low-rise building, really houses or really small buildings. The implication of these membranes are not so intense when we are talking about buildings 20 meters, 25 meters, 50 meters height. That a fire, it is really a problem. So this is really an impact, a difference between a high-rise building and a low-rise building. So yes.
Okay.
So,
okay.
Yeah.
Okay. Then my thanking for using it as Redmond. You are most welcome, Mike, as you know. Thomas, are fire test reports available? Miguel, would you like to answer this one?
Yes, we have all the membranes that we are presenting here. They are full backed with testing. Technically based on CE marking as well, 13501, and even additional tests in terms of fire. Yes, So we have all the testing correct.
Yeah, and then I have here from Alain, what is the benefit of the VCL membrane being watertight?
Okay, good question. So sometimes, you know, in a really good construction, good scheme of the facade, we never has water inside the facade. But sometimes we know that sometimes workmanship, a joint that was forgetting to seal, we have water. So the point is, if we have water inside the facade, we know that our membrane is watertight W1. So and by the way, it's a mandatory test on the CE marking for as a VCL. So water tightness is a mandatory test on the VCL membranes. So I believe that that it's important that if anything happen in the front, we know that our membrane is totally watertight. So we will not have any water inside the building. This is not usual, but we never know.
Okay, very good. So just one last share from Mike. At EWA, we are using the FRVCL as part of the drywall assembly when we have composite lightweight facades. On the Redmond project, when had the full fire test to UK British standards. So yes, this is a very specific project. We have it was a very good job, still ongoing. But I think I don't know if you'd like to add something to this, Miguel.
No,
okay.
No.
Yeah. Okay. We'll return back to the chat. Maybe we can just keep going, Miguel.
Okay. So sorry, Enrique.
Yeah, and
yes. So yes, go ahead, Enrique.
Okay. So here, just because we were mentioning and myself about the easy installation procedure that we have with these membranes, we would like just to very briefly share with you what are the main steps when we are installing both on a range screen cladding, on an SFS cladding system. So we just going through some details. Miguel, if you could just change. So here in the first slide, we have like a demonstration, a drawing when you can easily understand that we just apply some lines of self-adhesive tape in order to temporarily fix the membrane to the substrate. Okay, and I say temporary fix because you know that after that it comes the cladding bracket. If we're talking on the interior, it would be the plasterboard fixing. So, but every time we have a self-adhesive tape that we can apply approximately half a meter space between each line, and then we just come with a membrane on top of them, as I was already explained before. So it would be the same. This would be the same in both systems, and then we have some overlapping details here. So very simple as well. We have in some orientation 150 mil, and the horizontal lapse we have 100 mil, but just a matter of overlapping the membrane rolls and then playing with self-adhesive tape. And this self-adhesive tape, we try to be in any solution that we have the same to change the less that is possible. But more than that, we'll be able to look into your project and to understand what's the substrate that is involved and what we need or what's the best accessories from our portfolio, from our knowledge that would help, that would perform better in that specific case. Okay, but it's just to understand, just to let you know that the instructions are really, really easy and clear. Yeah. Okay, here's just some details, and these again are some pictures that I took from the site, and so we have some pictures showing breathable membranes installations, so screwing points, bracket fixing, some difficult shapes to play with in terms of perforations and elements crossing the facade, and some coping details as well. So this is always present. And when we're designing and looking at the breathable membrane, it is all these things sometimes look or seems not to be very relevant in terms of the designing, because it would be solved on site. Okay, and in fact it is solved on site, but we can previously try to understand all these points and all these things would be covered. And so as we are here in this session talking about fire and the fire system, okay, Enrique, but if we have more tape and more accessories to this installation, wouldn't that compromise the system as a fire rated system A2? In fact, no, because we, for instance, if you look at this second top image, or the one in the center top, it's like having lots of brackets, and this is not a very particular case. We have this often. And we have a specific tape that you just apply on the back of this perforation, and it's automatically sealed. And this tape was considered in the full test. So when you're installing this tape on the back of these brackets, and doing so, you are ensuring that there's no leakage possibility through that thousands of points that you have on the facade, just perforating the membrane that you carefully has designed before. So we have this tape. It is certified in terms of fire because it was included on the test, and maybe we'll have the chance to share some mock-up drawings later and explain a little bit what was considered. But these tapes was considered, the overlapping tapes were considered, the fixing tapes on the back were considered. But these details, these perforation details, we really think it's something that we need to look at and try to be more careful when dealing with this specific perforation.
Okay, Enrique, thank you so much. So and then we end up on that today the session it is that we have a breather FR A2 breathable system and A2 fire rated system tested with accessories replicating the facade on 13501. So here I'd like to be really fast. I believe that more than you know how is perform this test, but it's basically is when we have a class A2 membrane, we it's each class on this test you have to fulfill each standard and then a criteria. So for instance, on the class A2, we need to do the ISO 17116 and also 13823 and fulfill all of these criteria. And we have this 13823, it's a corner that we expose totally to the fire the membranes during 10 minutes, more than 600 degrees. Here it is the calorimeter test. So each layer of the membrane and each layer, each accessory, it's created on it's fulfilling all of this wall. and then it goes internally a machine that measured the calorific power of each layer, standalone and summarizing all of them, and you cannot reach to these criteria, these levels. So, and then we fulfill all. In the top of that, we also add the best class in terms of smoke and in terms of droplets. So basically, this is a summary of the classification and then the results. Okay, uh, is that? So here it is something additionally, because the other test it's enough. The regulations, they only speak about 13501 when we are talking about standalone products. However, I decided to bring this test because it's useful when we look at, okay, there are a fire, but how it looks, the membrane become black, the membrane degrades, so how it is. So, and then this test, it was a full scale mock-up, BS8414. Here we see the cladding, the rain screen cladding, the rails with the fire barriers and fire stops. And then it's not here, but there are a cladding on the top. Here there are a detail of the fire barriers, fire stop, and then start burning here. So it's like a wooden rig that burns for half a minute, and the test is 60 minutes. And here it's post testing, so it's the observations of the test. And here we see that everything goes. So the fire is so intense that burns the cladding, burns the membrane, so burns all around. So this test, the function of doing this test, it's try to minimize if we have a fire in a kitchen, a fire in a balcony, for instance, the balcony here, the fire, it will not reach to this level. So it will not break the glass and propagate to the level and level and level. So if you see the fire stopped here, and then what it's really interesting here to see, it is to see how the membrane that we are talking about, the membrane, if it's very far, how it was. And then we clearly see here that there are a fire barrier here, a fire barrier also here, and again here. And one thing that it's interesting to know, this is the worst part, the cladding, hole, and then the membrane. But one thing that it's even the fire stop, one thing that it's interesting, all the elements work in conjunction. For instance, it's also visible to see that it's full black, the membrane here. So it looks like this fire stop here, let the flames, let the smoke goes to this different level. And if you see after this fire stop, the color it's also different. This means what? If we have a combustible membrane, we might have a really nice cladding, nice fire stops, nice fire barriers, but in the end, after crossing this fire stop, it starts burning here. And then it could jump the fire stop and start burning here and propagate and propagate and propagate. Here we clearly see we are decreasing the fire. We are contributing to the fire propagation. So I pick up this standard in order to visually to understand why it's so important to have a membrane like that. Another test that we do in parallel is a ACTM E84, that it's a 7.5 meter long test. We place the membranes on the top of this steel tunnel, and then in this part here we replicate a fire around 10 minutes, and then we insert airflow, and then we start burning here, burning with organic material. And then what we measure, we insert airflow, and then we measure on these small windows the flame spread of the material, and then in the end we measure the smoke development, and then clearly see here through these photos. Photo number one, it's the photo before testing. Photo number two, it's the sample before testing. Sample number three, this is divided in three samples. So here we see from the beginning of the sample till the end, and we see here that it suffers a lot because it's in the fire zone. But we see here in the end that we don't have anything. So imagine the fire starts here, and then it starts and ends here. We don't have propagation on the fire. So imagine on the facade, if we have the fire here, the fire will not propagate. So this is like visually something that you could understand, that the implications on your facade project. We ensure that the skin will not propagate. It will suffer on the fire location, but it will not propagate. Again, you know, in the end, I also bring this test, really important test that we have done with the other membrane, Effisus Vapor FR, in the top of a combustible membrane. So imagine we were quite reluctant to understand because we know the results here. We don't know these results here because we are covering, so we are trying to wrap a combustible material. And then the same tests, ACTM 84, 7.5 meter long, we replicate a fire, 10 minutes, around 700 degrees. And then the results of this, and then the membranes, the both were attached by a small patch of one of our tapes in order to ensure a completely bond, a sandwich between the both membranes. And the result, it was incredibly, after 10 times, a flame spread 0 and smoke development 0. So this allow us to say that our membranes, they really protect, they really minimize the propagation, even if we have combustible materials behind. So this is something that I would like to share with you guys, that we are really, really comfortable with the product, and that's all. So so I don't know if you have any questions, Enrique, if you could help me with some questions.
Now you hear me, I think?
Yes,
Okay.
now it's perfect.
Okay, so yes, I was saying that we have still at least 2 questions to answer. So one is from Bruno. What is the difference in procurement cost when between an A2 membrane and a non-pyrated membrane for 1,000 square meters? So Bruno, indeed, there is a difference, as I shared before. So as we already said, we have many different breathable membranes on the market. Some of them with the same fire classification, and the difference to an A2 fire classification can vary a lot. But we can be talking about if we're saying like an E class membrane, a single layer, 3 layers, class B, so many different membranes, open for open joints or not on the cladding facade. But we can say that it can go maybe into between 2 and 3 times current breathable membrane. But if we're talking about, and I really appreciate that you've picked up this topic, because we really need to understand what's the implication that it has in the full procurement process in terms of offering a facade system, for instance, to your clients. So these membranes, even if it is 5 times higher than the current cost of the membrane, for sure you understand it will still be a very little percentage of the full facade package in terms of glass, aluminium, everything that is involved when you're playing with a facade. And what are we playing when we are deciding if we should choose a membrane class A instead of a membrane class B or lower than that? So yes, the technology of production is different. Um, the projects that are featuring this kind of A2 membranes are are for now less than the ones that are with the B or even less breathable membranes. And so this is a process. This is an ongoing process. But what I would like to highlight in here, in this answer, is that we really need to understand this balance between the extra cost for adding, for making this step forward in terms of fire classification, and the cost that we have on the facade. So, but that's more or less the difference that I would like to share. But again, there are very different prices. But if you just give me a call or text me directly, I'll be able to share all the prices with you and everyone. So we have more questions. Another question from Alain. Do you make class A or B damp-proof course material? So I suppose this is for the interfaces with the roofing, for the interfaces. So for the cavity trays, maybe. Miguel, this is.
I believe, you know, it's Enrique, damp proof. It's generally damp proofing. It's only on the foundations where there are a lot of water. You know, it's generally it was a material that was used to do cavity trays as well. So I believe that the client is pushing for a cavity tray solution. I believe so. I don't have 100% sure.
Okay. So in this case, I would say that we have technology available, because foundations is not very much where we are in terms of our portfolio of solutions. But if we're talking about interfaces and things like cavity trays or like interfaces from the facade to the roofing membrane, so we give support on all those queries. We have, as we said, technology available and certified in terms of having the membrane and the accessories already tested in some conditions. We're able to adapt, to adjust it to your project if we need to do something more than what we already have. But again, we have the technology, we have the product. We are already developing something for the cavity trays, for instance. We have some prototypes already tested and approved, for instance, with class B. Okay, and we'll be able to share this with you really soon. But more than that, Miguel, for instance, and his team are trying to get from the market feedback on the very specific requirements for cavity trays, for instance. That's something we were not playing. Okay, it was not part of our portfolio, but people chase us very much because of the of understanding that we have this technology and the full backup from the weatherproofing. And so we are working on this and other stuff, and so you may expect very soon to be or contact by Miguel in order to get more information on these movements, because every project is a different project, or to get a new product released on the market. So this is a non-stop process. In terms of damp-proof course material, if we're talking about interfaces, we can already play with the membranes that we already have. Okay, breathable membranes, VCL membranes, those are ready to be waterproof and to make connections between different materials. But still, we need to look project by project. We have to make sure that the movements are controlled. Okay, we cannot. If we're playing with a specific membrane, we need to understand how it will perform if we have specific movements. So this is not only changing, for instance, an EPDM that everybody knows from the market, but that's not that's fully combustible. So that's class E in general. For a non-combustible, breathable or VCL membrane, because if it was that simple, we would just use our A2 fully certified membrane. So that's it. But again, just answer directly to Alan. We can look into a very specific project detail. So please feel free to send me some shots, something that you'd like us to look at it. And if we have some questions in order to validate our solution, we'll just send them to you back and make this happen in the most sustainable way, okay, and comfortable way. Again, Alan is asking here, subject to hydrothermal analysis, can the breather membrane be used without the VCL on the inside? I believe Reptides promote their membrane in this way. Miguel?
Yes, we have our own opinion, so we don't go on that line. So we, for two reasons. One of them, it's we really need a VCL in a way that we are not adding moisture to the water, moisture to the insulation, in a way that during the summer, because this is the way that it works. We are adding water and moisture during the winter and during construction, and then during the summer it will getting dry as much as possible because of the temperatures depending on the ventilation. So not providing a VCL, so we are adding more moisture along with the water that it's already there during the construction. We are adding more water than the water that we get out during the summer. So this is one of and we could see this year after year. We are having the levels of water growing up inside of the insulation. Second point is the workmanship. So the point I'm not comfortable to have exterior because exterior it's always a nightmare with the scaffolding, with the environment, temperatures, adhesion. As you know well, internally environment more controlled, and external it's a nightmare. So I don't believe, or I'm not comfortable in my projects to have external one membrane applied externally, a lot of perforations. It is balconies, it is electrical cables. So I'm not comfortable. And if there are a failing on the joint, I don't have anything. So as a safety measure, I prefer to have a second membrane for two reasons. Double protection. If anything fail on the breathable membrane, on the cement particle board, I do have another membrane that protect my building interior. And then I have a block that I'm not adding at all water inside insulation. So this is our way to look to the same aspect.
Okay, Miguel, and just adding to your answer, every project is a different project, and we're able to look at every single project and understand the specific needs.
Correct. This is really, really important, Eric. Each project, I'm saying this in general, each project we look at deeply in each cases. So I think I did not say it from the beginning, but we work with our clients project by project. So we produce weatherproofing design. So we do drawings, we do technical submissions to our client, depending on each client, depending on each standards. So we deeply are involved in each detail, in each facade scheme. Yeah, this is really important, Eric. Thank you.
Okay, welcome. So from Pierre, and hi Pierre, hope you and everyone in your team are well. Thanks for the invitation. Very interesting, especially in this section with tests. Is there any progress in developing a fire-rated membrane for dynamic joints? So I think this very much aligned with my answer before. Yes, we have technology. Yes, we understand that there are specific requirements from specific projects, from specific details and joints, and we are working in this. Again, if you have a very specific project, something that you'd like us to add and comment, please feel free to send it to us, as we'll be more than happy to help you through that. And from Mike, again, thank you very much, Mike. We use the VCL to avoid interstitial condensation migrating to the outer phase.
Correct.
Okay. So I think we can move forward now in the presentation, Miguel.
So yes, correct, Enrique. So this testing and you know, Enrique, you will be the guy. So this is not the art. So we are using these membranes. Our clients are already with a good practice, and we have and we are using through the Europe, through UK, outside Europe. So there are projects, and we still my side that I'm more linked to the consultants with the architects. You know, I really share with you guys. We see a tendency, we see a way to A2. You know, it's really in all the projects, it's specified, or most of them specified class A2. I don't know, Enrique. So if you could share your feedback from the field, what is going on this project ongoing, it will be really, really nice.
Sure, Miguel. Just again, very briefly. These are some of the projects, and as Miguel was saying, what we'd like to point out with this is for you to understand that this is not under development. This is already been installed, and some of them installed very long time ago. So here we can see, for instance, some projects in London, in Ireland, in Liverpool. Kensington Row, Millbank, Ergon House, Navigation Square in Ireland, the Raymond project here that Mike already talked about. And if you move forward, Miguel, we can also see other projects in London, so Whitechapel, the City House, and in Onslow, the Bath Road project. So both of them, and we're talking about projects that are featuring A2 class membranes as the breathable one or the VCL, or both of them, because we truly recommend the full system envelope. And then we have here some additional projects ongoing on the UK. So this is King's Cross at the left, and Alton Park at the right.
And we have, you know, from my side, we have a lot on the pipeline already specified in the tender phase. Yeah. Eric, and here it's outside UK, more on Middle East, Arabia's, that we have iconic projects using the same technology, more on the vapor FR membrane, but yes, really portfolio. So that. So I don't know if the chat room, Enrique, is if we have any other questions.
I think Ala, Ala was asking if the cladding on the building lower right was the one used in the BS 8414 test. This was the test, the mock-up test.
I don't know. I have no idea. So I don't know.
No, but do you know which test is Alan referring to? Maybe one of those. Of the ones that you shared before, if you could just maybe go back and understand which picture we're talking about, because I think it is project in here, the Raymond.
Okay. Yes. That one.
84. Yeah, this one.
Okay.
Okay. So yes, this was a mock-up for that specific project. Yeah. as you see, the claddings are much the same.
Okay.
So I think you can move forward now, Miguel.
So we were discussing portfolio, and then we have in France as well that it's not here, and it's all. So summarizing, so the product it's being used in Europe, in UK massively. I could see, because I'm in the front like 1 year. The product is specified in a lot of projects in UK, and we see really we see, as I told you, I don't want to say it again, but we see a movement for Class A2. And you know, by the way, the government, you know, I have information that everyone is pushing to change the regulations to be like a benchmark or to be full Class A2. So as I said from the beginning, this is not more technical, but it's also liability. So we should, in our job, in our designs, at least specify what is the best, you know, in order to avoid problems and losses in our projects, in our construction. So this is, so I'd like to end on that. And here I pick up the opportunity to say that we write technical articles that it could be detailing, it could be designing perforations on the facades. Next week it will be launched another one that it's calling about service. So how is important service in not only products, and I invite you to stay connected on these technical articles, and even as I said from the beginning, next sessions will be here close to you. Any questions, I have my email here, so we are most than welcome to speak with you, collect feedback, even create another thematics. So what I would like to say here, this is not, as I said on the beginning, this is iterative. So we want to speak subject that you are interested. So as much as possible, send us feedback, technical queries, project that you like to study. So we are here with you, trying to these times pass really, really fast. Thank you so much.
Thank you very much. Thank you. Bye-bye. Cheers.
Bye-bye. Cheers.